Good morning, or good afternoon, or good evening, while you're probably having a beer or a wine at the other end of the world. We in the Netherlands here are happy to have our morning coffee. So I welcome you to this session. My name is Mark de Gouw. I'll be your moderator. I'll be watching the Q&A and posing the questions to Grahame at the end of his talk. And now we move on to Grahame, who is going to talk about a very interesting subject, a FHIR Façade server in front of other FHIR servers. Well, Grahame, the floor is yours.
Hey, thank you, Mark. Lovely to join. Thank you everyone for joining me. Hopefully we can get this going. So, this is a subject that a lot of people have raised over the years. So hopefully I can bring you a little bit of light to this subject. You probably all know who I am now. I'm the product director and community lead for FHIR. So what I want from this presentation is to describe so that you know the likely challenges you'll face if you decide to put a single facade over multiple servers, and to have a sense for some of the choices that you can use to solve the problems that arise. Now, many of the problems are not easy to solve, but we'll see how we go. Forget that slide, I'll take that out. Okay, so here's the scenario that mostly we're talking about. You've got, on the right, you've got a client that wishes to consume a bunch of FHIR services. In the middle, you have your Façade server that provides a FHIR server to the client, but it doesn't actually have any data of its own. It gets all of its data from the source data systems, multiple source data systems. Each of them are separate, partially related server. Now, we don't know to what degree they're related, but they're all providing data that you wish to consider as a single server. So they must have some consistency in order to do that, at least organizational policy and control. Now, I want to point out that this particular diagram, let's talk about assumptions before I do that. So let's make some assumptions for the sake of our presentation. The client's only dealing with one server, the Façade server. It doesn't need to, and it doesn't know about the back-end servers behind the Façade server. As far as it's concerned, it's dealing with a single server. The back-end servers, in this case, the back-end servers are implementing a FHIR interface. Now, a lot of cases that's not true, and so there's a degree of like, well, it's not quite FHIR, it doesn't really work the same way. There's a set of constraints around that. That's okay. The underlying principles are often the same. Sometimes there's more challenges from that, but I didn't want to go into that too much. And so, the same principles apply. We think that some kinds of resources are on one server, and they're like, for instance, you may have a PMI server, and so all of your patient information comes from the PMI server, whereas you also have a lab server, and all of your diagnostics reports and observations are going to come from the lab server. But then you have some resources where resources of the same type are on both servers. So maybe you've got a hospital network, you've got your PMI, you've got your lab, you've got EHR, you've got a gastro and a cardiac system. All of those systems are going to be contributing observations to the client. So resources like observations will come from multiple servers. And I'm going to assume that you have some degree of administrative and development control over both systems. And you'll see where that becomes relevant as a problem that you should, as a control that you're going to need at some points. Now, you may have, incomplete control, and that'll make some of these solutions more difficult. So those are my assumptions that I'm talking about. want to point out that this is an actual like conceptual equivalent of having a single file repository that you populate from multiple sources. A lot of the challenges are the same challenges, and they're around combining and reconciling information from different sources and what it is that you need to do. And so while a facade server has some particular constraints around the way it operates, most of the basic problems are pretty related. And there's a gray area as well between the problems that are FHIR specific and the problems that are more generally record keeping issues that you need to, you will come up whatever you're doing. And there's no, there's a gray area between the two. So in terms of challenges, I think that your general challenges, the first is around managing access rights and security. Most of your time will be spent either on that or on managing identification of resources and references, and combining search kind of comes into that because it's where you actually combine content from servers. But underlying in the background, in your challenges will be around inconsistent record keeping, inconsistent underlying business practices, and distributed business logic that crashes into each other, or into, nested complicated processes that crash into each other on the Façade server. Actually, the latter two are probably going to be harder to solve, but they're not FHIR specific. So I won't be talking about them so much. So let's talk about managing access. So if the client's only dealing directly with the Façade server, that means that the user's going to authenticate once with the Façade server. Probably conceptually they're using OAuth or some variant of it, and the Façade server knows the user, manages their tokens and their sessions, and is responsible for the overall security of the system. It's a pretty common approach, and mostly that's why you're doing a facade, to abstract the security away from the factory systems that you don't have so much control over. And this is, a specific case of the general case of what's called an API accelerator. And so since the facade is managing the access, the obvious question is, who approves requests from the client and who approves the response that's going to go back to the client? Now, what I'm going to show you is, the point of an API accelerator, a Façade server, is to do this on the Façade server. But what I'm going to show you is that it cannot be just the facade. So let's take as a scenario that we're dealing with a user. The user has rights to see multiple patient records. They're not a patient constrained only to one record. They're a clinical user. And so they have access to see multiple patient records, and they can search for patients that meet a particular clinical criteria. The user doesn't have the rights to see selected VIP patients. They don't have rights to see information pertaining to the sexual health clinic at the hospital, at the institution, and they don't have the rights to see HIV-related information. This is a standard user profile at most healthcare institutions in Australia. And I think it's probably the same in much of the world. This is a common scenario. So let's keep that in mind, and let's look at some scenarios. So we get a patient, we do a request for a patient to the facade. The facade goes to this back-end server, and I'll come to that part, and says, get me the patient with this ID. A patient comes back from the back-end server, and it has a security label on it that says the patient's a VIP. And there's a technical security label in FHIR for this purpose. So the facade says, well, this user's not authorized to see a VIP patient, so we'll return a 404 OK. 404 not found, sorry. Whereas if they do have a VIP, doesn't have a VIP security label, fine, we send it back to them. So the security is applied on the Façade server on the response processing. Still means you hit up the client, the back-end server, for something that's not authorized to be done, but you can only decide that once you see the patient. And then you say, get me all the patients with the name of Peter. And then what happens is you do that search on the back end comes back to the front end, the facade with a list of patients. And you just strip out any patients you see with a VIP label. There won't be many of them, but there will be a few. So what do you do if the request is count equals 20? So you're specifying a page size. Do you drop it out so that the user knows that there was a resource they couldn't see? No, that's a problem. You can't do that. So immediately you see that filtering the response raises problems with page size. And so you'll have to figure out, some way of doing that. Maybe the page size from the back end is bigger than the page size the client requested, in the hope that you get enough, or maybe you just have to go back and get the next page from the Façade server. So immediately it's starting to get more complicated to deal with stuff like that. But you can do that. Scenario 2, we're going to fetch observations. In this case, the user does a request for all observations with a link code of 25835-0. That's one of the PCR HIV tests. This is an HIV request. The patient's not authorized to actually ask that. Sorry, the user is not authorized to ask that. So we don't bother hitting the back end. We just send a 404 back to the user not found. We don't find that. Well, there's a challenge here because there's like 400 relevant link codes. There's another few hundred SNOMED codes, and how much business logic do you want in the Façade server around that? So that's starting to get challenging. But what if the server sees get observation with a code of 25835-0 with no link, no explicit link? So look at that, go, well, they can't do that link code search, but I don't know what else 258350 might match. It might match some other server. So we can't. We'll have to tell them they can't do that kind of search because it's unclear whether what exactly they're searching is ambiguous, and we can't tolerate the ambiguity in our split business model because we don't know what 258350-0 might map to, but we know that it can't map to link. So that's kind of, well, we may have to say you can't do that. But what about an observation code which is more difficult? So 45246-6 is actually an observation about the sticking to your retroviral therapy. Is that in or out? That's starting to get, it's hard for a Façade server to decide. I don't think you can do is to say, well, I don't do all that. It's too hard for me. So I'm going to pass the request on, and I'm going to strip any responses that come back with security labels. So here's the security label for an HIV test. There's a bunch of other security labels you may need to be concerned about in this case. So first of all, you need to be confident that the backends are actually going to return the specific security labels so that you can make those decisions appropriately. And the backend can't because it doesn't know anything about the user, right? It just got an unsecured request, and it's got to provide everything that might be available to the user so the Façade server can decide. But then it gets more complicated because what if the user does in request just to count me the number of tests that there are for HIV tests? The server doesn't, the Façade server doesn't know because it doesn't see the responses. And so where do you apply the security in this case? So you're starting to see that it's pretty hard for the Façade server to do this. One possible answer is just to say, well, we won't do any of that, and I'll come back to that in a second. But there's an even more difficult subject. So let's say we select a patient, select observations on a patient. We select observations by the encounter patient for patient 234, or we get observations on the subject of patient 234. And the difference, if the patient has an encounter, The difference may tell you if they've had a sexual health clinic visit, even though you don't have the right to see those encounters, because the facade server doesn't have the insight into the fact that there may or may not be servers. The decision-making logic in this case is made at the back end. It's not made at the front end. And you can't enforce that security on the facade server. It's got no insight. And really that kind of decision, once you get into chaining and you've got some kinds of criteria that are out of the explicit query that affect which chains are eligible for search based on who the user is, that has to be decided down inside the search engine. So what we can say is that implementing security is a joint responsibility of the facade and the back end. Now, what I recommend and do generally is that any facade or API accelerator or proxy server of any nature that's doing any user authentication should pass a JWT that represents a signed statement about the user in the headers to the actual backend server. And in this case, the JWT from the facade server will say that the user's got these authorities and to search according to these authorities. The server trusts that the facade server has authenticated the user and got the security model correct, and it just implements that. But obviously you need to be in control of the servers to make this arrangement happen. It doesn't happen without being managed. So that's why I say it's important to manage both in this case. And a JWT is, a good standard form to manage this. The other choice you really have is to say, well, what we'll do is we'll identify any opportunity on the API for slipping one by the facade server, so it can't enforce the security. And any opportunity that we find, we'll just remove that feature from the API. And actually, you don't get left with very much API once you start doing that. It's severely restricted, and it's not a great experience for the users or the clients that represent the users, because you just move more and more work forward to the client and everything becomes more laborious. So in the end, I strongly recommend that a facade server collaborates with the backends around security. Now, the other obvious problem, and one that has generated a lot of conversation as we've gone, is managing identification and references. The basic problem is you've got multiple servers for one resource type, and this comes together in search. So your general approach is the client issues a search to the facade passes that search on to multiple servers in parallel, or multiple ones of them at once, then it hears back from all of them and assembles a final bundle by collating the results from the multiple servers and then sends back to the client. So first, an obvious problem, which has no obvious solution, is what do you do if you don't hear back from all the servers? How long do you wait before you decide you aren't going to hear back from the servers you haven't heard back from? That's a hard problem, but while it's got no obvious solution, it's got obvious compromises to make. So let's assume that you make some compromise there and you're assembling the final bundle. And let's talk about assembling the final bundle. So you've got a bunch of resources from all observations. We're going to stick with observation, and they've all come from different servers, and they all have identities for which they are identified on the backend server. So you may be able to assume that the identifiers you got, there should be resource identifiers. The identifiers you got are all unique because all the servers are using GUIDs, and you've decided that GUIDs are reasonably functionally unlikely to overlap. That's a fun IT question. And so you can just say, well, I'm gonna assume that they're all distinct and I don't need to re-identify the resources. This is a good place to be in, but unfortunately it's not that simple. Alternatively, you could look at all the resources and say, well, it's possible that the server's resource IDs could overlap because they're all issuing from their own private primary key generator, probably a database primary key. So what I'm going to do is prefix each of them with a code for a specific server. So probably maybe S1 for the first server, dash, and then the ID that I got from the source server. Now, IDs are limited to 64 characters. So that means that the source server has to be limited to 61 characters so that I can prefix it like that. 64 characters is a heck of a lot of characters, but we've had a few users who said, I've run out of characters because I've got chains of this stuff going on and I've got complex IDs and 64 is not enough. Can we have 128? So 64 characters is actually an external standard, but as far as we're concerned, if 64 is not enough, nothing will be enough. People will just keep making up more longer IDs. You've got to work with what you've got. But you can prefix them. Alternatively, you can just replace the ID with your own ID. And just generate a unique or random a unique ID. I wrote random, and it's random from the point of view of the client that's consuming this, but it can't be reused. You can't take an ID, assign it to a resource, and then randomly assign the same ID to a different resource. So you re-identify every resource. Now, you can, and you probably should, maintain a lookup table, so that you record the ID that you've got and then the ID that you reassigned it to for later reuse, so that each time you see the same resource, the same record, you assign it the same new resource ID and there's consistency. Now we have some implementations where that's not possible because what they're getting from the backend is not identified. So they just stick a random ID on the resource and use that. And it will never, ever, the same information coming through each time. We'll get a new ID each time, and we'll gradually fill up the cache of a client. That's not great for the client, but it's not illegal, right? You can just keep issuing new resources that represent the same record. What you can't do is reuse the same ID for a different set of information. But if you start re-identifying resources, you now have to go through every reference in the resource, references, canonical URLs, extensions, and even references inside the HTML, and updating the resource, updating the reference to be consistent with the new reference you've given it. Whether you made up your own or you assigned a prefix, you've got to go and chase them all down and make them. That's okay. It's a one-off thing to write the algorithm to do that. It's pretty straightforward. And it's but it's, you've got to do it. It's a computational hit on the server. But you need to do something about this, because in most cases, what happens is the client will later refer to the resource and you'll need to remember that reference so that you can resolve the resource to the source server. Maybe it wants to get a copy of an updated version. It remembers that it was resource, 123, and so it says, give me resource 123. If you prefixed it with S1-123, then you just whip off the S1- and forward it to the S1 server. That's pretty simple. Or if you're maintaining a lookup table, you look up 123 in the lookup table and then hit the server it came from. But of course, you have to do that work. Another option is that you don't support gets, right? You just do search, you get what you get. We don't. It's not a memorized ID. Yeah, well, it's its own problem. It's not a matter of conformance, but clients like to be able to read the information. So you're either going to be prefixing or lookup tabling. It's going to be one or the other, or not doing get, not doing read anyway. So yeah, you got to make your choices around that set of options. If the server starts accepting writes, then you've got a new set of problems, because if I post a new observation to the Façade server, or which server does that actually go through to at the back end to handle the post? And for that reason, actually, facades are mostly associated with read-only servers, there's specific kinds of operations you can perform that have a known mapping through to a back end. That's typical. Where does the server log? Or maybe the Façade server logs to its own log, and then you're stuck manually into connecting between the two logs. Or if you've got a common, in-system enterprise logging solution, do both log to that? So you've got some questions like that. But then you've got a series of questions around joins. Can you join across servers? If you get a request from a client to join from observation to patient, but your patient server is a different server to observations, what are you going to do about that? What are you going to do about page size? So it's a classic problem. Now, all of those things have solutions. They're all compromises. They're all inefficient somewhere. It all depends on your local business continuity and logic and conditions. So there's no magic bullet to any of that. And I wish I could tell you that there was, but there's not. Now the other problem is record alignment. If you're going to say, I've got a request for a single patient, and actually I'm going to pass a search, for observations on a patient through to multiple backends, do all the multiple backends use the same patient identifier? Do they use the same encounter identifier? Are they in sync with each other? In a typical ecosystem, the servers are only mostly in sync with each other, and you've got loose ends to worry about. And this is a typical place where those loose ends will bite you, where you put some kind of seamless interface over a non-seamless infrastructure. And those are deep structural problems that predate FHIR. It's not a FHIR thing. It's inherent in the way you keep records. And then to what degree are you concerned that you did a query on multiple servers, you got back a collection of records, and those collection of records are duplicate records with each other. They're genuinely different resources, but they represent the same real-world concept more than once. What are you going to do about it? Are you doing anything? If you're a pure FHIR technical architect who only cares about the facade, you go, not my problem. But if you're a user of the Façade server, it's absolutely my problem. What do you do about that? What does any consumer of the information do? And actually, it's the institution behind the facade that may know to some degree what the answer is. Now, what we're actually talking about can be turned a little bit and say, what happens if there's the client that you're talking about hitting the facade is actually building a persistent store? So far, I've mainly focused on the facade perspective of the problems. But if the FHIR client is actually remembering information, then that ups the pressure on the facade to be a good citizen. And so this is a fundamental question when you're writing a facade is, what goals do you have? Do you want to serve a client that there must be ephemeral and doesn't persist information? Or is it your intention to support a client that fetches and stores information and caches it and maybe shares that with more repositories, like a patient-specific data repository may be built from a facade of facades. In effect, it becomes an aggregator of multiple facades. So there's a series of questions that arise that then reach back and say, what do I need to do on my facade to make these reliable? None of these have easy answers. So the thing is that the client in this case, which is a persistent store, needs to get records from the Façade server, the source. It can consistently query patient everything. So we're now sort of in a single patient in space, or it can simply do what everything logically does and just do it consistently. Or it can just add last updated to all its queries, or use a history operation. But all of those, I mean, did the Façade server support all those facilities? And if the Façade server supports them, how does it support them? What does the Façade server do with last updated? Does it query all, assume that applies to all the servers? And the last updated value comes from the server in the first place. And their clocks, let's assume their clocks are not totally synchronized to the microsecond. So you've got a bunch of questions around, what time do you remember is the time of last updated to report to the client so the client can reuse that. Alternatively, the Façade server could offer a subscription interface which is another whole world of pain that I haven't even mentioned, which is what does a facade server do as a subscription server representing a facade to subscriptions? So that's yet another question that we may come to one day, but we've not much spoken about the challenges of that. And they just kind of like permutate everything we've already been exposed to. So there's a problem of, and the facade server kind of needs to actually have at least a documented answer to this, even if it doesn't get directly involved, is how do I know which resources belong, which records belong to a patient? What would I query for? Then there's the patient ID question that I talked about. And then the other one, what happens about resources that go missing? And this is particularly more complicated and more prominent on a facade server. So what happens, I asked at the start, what happens if a server doesn't respond to the facade? How long does it wait? But if it doesn't wait long enough and it sends back and just omits any mention of the resource from a server that didn't respond to it, what does the client assume about the fact that a resource wasn't present? Does it mean that it's deleted? When does it delete a resource? The whole issue of deletion is really fraught anyway, and it's more difficult with the facade server. All these other reasons also apply, although honestly in some hospitals I've been in, you might have information deleted from one server that's still retained and shared from another one, even though it's no longer supposed to be. So that also could potentially be a problem for the facade server. And then, of course, the security issues. So I decided I'd mention these. They're not strictly directly a facade server problem, but they're just more challenging on a facade server. I have a reference here to a blog post I wrote describing some of these problems. And of course, there's patient merge problems, because just, like nothing can be, if we weren't already complicated enough, we know about patient merge, that it happens, records get merged and they get unmerged, which is impossible, but it happens anyway. And so if you're a facade server, you cannot be agnostic about this. You need to ensure that all of your source systems are marching to the same beat on how they manage patient and encounter management and merging and linking. If one system merges and another links, then you can do queries on a client on behalf of a client that have totally incomprehensible results because one of the servers linked and the other has merged. They're not telling the same story. And you can't even assume that they actually merge and unmerge and link and unlink in agreement with each other. I've certainly sat in lots of meetings in institutions where different record keeping systems in the institution don't agree about who the patients actually are, and they don't agree with each other to merge or unmerge. And so in the and then you have the problem, if a patient's merged on the PMI, does that mean that you treat them as merged on all the other systems? I can't tell you the answer to these questions, but I can tell you that we have unsafe systems today because we don't agree about how to handle patient merge in the simple case, let alone in the facade case. Yeah, both cases. What happens if you actually ask for a patient that's been removed? What happens if you ask for references to a patient that's been removed? Nobody agrees today about what to do about that. All right, so I've left a good set of time for questions. What I want you to know is what the likely challenges, based on my experience and in our discussions that we've had over the last 8 years, both in public and in private, around how do you implement facade servers? What are the likely problems? There are many challenges to the problem. One, I mean, you can bow out of that and say, we'll just expose each server independently, and you move the deck chairs around because now the client has the same set of problems. So the problems basically exist somewhere. Someone's got to do something about the problems. Do you want to externalize it to the client, or do you want to build a single facade? There's no good answer here. But my general contention is a facade is not independent of the servers that it fronts for, and you need policy and development control over both. And security and identity are the key FHIR issues, but they manifest deeper record keeping issues that will arise, whatever. I've talked about some of the possible choices for solving these problems, but none of your choices are great. And the way I look at it, a facade server is a special case of the general problem of aggregating and integrating information. So thank you for listening, and I'm happy to take questions.
Thank you, Graham, for a great presentation. A couple of years ago, the joke was that FHIR is an acronym for far harder in real life. And this is certainly an exhibition of the hardness of problems in real life. We've got a couple of questions. First, there's a question by René Spronk. Most of the issues raised are about governance or are heavily impacted by it. Aren't there lessons to be learned from environments such as IHE, XDS, XCA? Many of these issues sound familiar to the ones faced in XDS contexts.
Yeah, obviously, some of that learning is from XDS contexts, and in as much as the problems I'm describing are actual underlying record keeping problems, not FHIR specific things, they'll absolutely come up in the XDS context. I think the XDS context is a bit easier because almost always you've got an aggregation that persists. That's the repository and the registry, or the registry and or the repository. And so you've got like a decoupling of the challenges, and then the client hits the registry directly and assumes coherency at that level. So that's one arrangement of the deck chairs. A facade server that's live and doing live queries onto back-end systems, there's a different arrangement of the chairs that kind of ups the pressure on getting it right, because it's coupled up. But the underlying problems will always manifest in any kind of approach you take here, and that includes XDS. And so yes, it's not like we haven't learned anything new. I think the only really new stuff from the FHIR community itself is around the search merge and the identification issues specifically. Other than that, it's not new stuff.
Thank you. Alexander Henket has a question. Identifying resources. He says you could also move things into contained, which restricts the scope of ID to just a bundle and prevents IDs that read as an option. So what do you think about that suggestion?
You can. We allowed contained, although you can't have a contained resource in a bundle. You have to have it contained in a resource in the bundle. We really allowed them for where you have basically anonymous inline resources. So you've got a doctor's name, but nothing else to identify the doctor. So you can't build an identified practitioner resource. And absolutely, some of your underlying systems will provide you with unidentifiable information like that. And so that'll be a real thing. And then you have to use contained resources. Other of your underlying systems will give you identified resources, but where you have operational issues with the identifier for one reason or another. Yeah, so look, you can sort of duck the issue by making them contained. But our general approach is to say that we hate contained resources and you should only use them when you really, really, really have to. But everybody's experience will vary around what really, really, really have to means in that context.
Thank you, Graham. Another question, Hendrik Jablonski, liked your statement about the length of IDs. What do you mean by don't support gets? Is a get on a single resource that should not be supported, like search only? Or what other gets did you mean?
Sorry, I should have been more clearer there. So both in the FHIR HTTP spec, both the read and the search are get functions. So you may support search, and that allows you to deal with kind of semi-identified resources, but you wouldn't support search with the _ID parameter, and you wouldn't support a read directly to just get with an ID, because your ID management doesn't allow you persistent IDs. So, I mean, there's a Dutch situation where that's the case because of the backend, the underlying communication framework for the backend systems. And so you support search, but not read. And that's what I should have said. I mean, you can do that. I think clients are put in a difficult situation if you do that, but well, you're moving the deck chairs around, right? There's no magic bullet on that problem.
Yes. I've got a question for you too. Lots of the problems revolve around resource ID. And you touched this in your previous answer to Alexander. Other than resource ID, there are usually business identifiers in the records. So isn't it part of the solution to rely more on business identifiers and less on resource ID?
Yeah, you have to, in effect. If you, but business identifiers are, well, I mean, if you look at the identifier, the identifier data type, there's a marker in the identifier for the sort of loosely the use of the identifier, which gives you some sort of sense about whether it's really reliable. I added a reliability flag on the v3 identifier. So you could say very specifically how reliable this ID, a business ID is, because there's some business identifiers are like a driver's license. They can appear all over the place because they're a proxy identifier for something, whereas other identifiers are really very tightly controlled and very reliable. They're issued by the primary source and they're not reused and nobody else hooks up to them. And there's kind of a range of reliability of business identifiers. So the great thing about FHIR resource IDs is you know exactly what they are and exactly how reliable they are, or that they are guaranteed not to be reused and not to have ambiguous meaning. You're not guaranteed they'll have persistent meaning, but you're guaranteed they won't have ambiguous meaning. Whereas a business identifier, you never have that guarantee. And so everything is more complicated. So you have to depend on them, but it's orders of magnitude more complex if you have to do that.
Well, thanks again, Graham. We've run out of questions, but we are also just a few minutes before the actual end of the presentation. So thanks again for a great session, and hope to see you again in one of the other sessions.